Use the matrix method to solve the following pair of simultaneous equations. We have x plus 2y is equal to -1, and we have 3x plus 5y is equal to 19. We are using the matrix method. So the first thing you do is you extract your matrix from the equations. So you extract the coefficients of our values. So in this case we have 1, 2, our matrix is 1, 2, 3, 5. Then you follow with xy, and this should be equal to -1 and 19. Then the other thing you do, you find the inverse of this matrix, then you multiply with it in both sides, left hand side and the right hand side. So let's find the inverse of our matrix. The first thing you find is the determinant. The determinant of this matrix will be 1 times 5 minus 3. This is -5. This should be -5, not +5. -5. So we have 1 times -5. We subtract 3 times 2. This will give us -11, because we have -5 minus 6. So we are getting -11 as the determinant. Then we take 1 over -11. We multiply with our matrix to get the inverse. So we have 1 over -11. We multiply with our matrix. Then when getting the inverse, you exchange the values in the principal diagonal. Then you change the signs of the other values. So we have 5. We have 5, which is negative. So this is negative. So we have -5, then -3, -2, and 1. So this is now the inverse of our matrix. So we use this inverse and we multiply both the left hand side and the right hand side. So we have 1 over -11, -5, -3, -2, and 1. We multiply with 1, 2, 3, -5, xy. This should be equal to 1 over -11 times -5, -2, -3, 1 times -1 and 19. So we have that. Then we have some rules that we follow in matrix multiplication when you multiply a matrix and its inverse. So you should always know that when you multiply a matrix with its inverse, you get an identity matrix. And when you get identity matrix and you multiply with another matrix, let's say B, you get the matrix itself. So in this case, when you reach at this step, this inverse times this matrix will give you identity matrix. The identity matrix that you get multiplied by matrix xy, you will have to get our matrix xy. So at this step, our next step will be xy is equal to, now you multiply what is on the right hand side. So let's multiply our matrices in the right hand side. So we have 1 over -11, 1 over -11, then we multiply our matrices, these matrices, then we multiply later with 1 over negative 11. So we have to multiply this row with this column and also this row with this column. So we have negative 5 times negative 1. We get positive 5. So we have 5. Then we take negative 2 times 19. So we get plus minus 38. Then we have also negative 3 times negative 1. We get positive 3 plus 1 times 19 is 19. So when you multiply this, when you add this, you shall get negative 33 and 22. So now we multiply our 1 over negative 11 with negative 33 and 22. So when you multiply, you shall get xy being equal to 1 over 11. We have 1 over negative 11 times negative 33. This will cancel with this, we get 3. So we shall get 3. Then here we shall get negative 2. Because we have 1 over negative 11 times 22. We get negative 2. So in this case, we shall have our xy being equal to 3, negative 2. And this will give us our value of x as 3 and our values of y as negative 2. So these are the solutions for our simultaneous equations. You can always substitute in our original matrices, original equations, and prove that left hand side equal the right hand side.